Welcome to this topic. In this lesson, we are going to cover quadratic expressions and equations. This is a Form 2 topic, and in our first lesson, we are going to cover expansion. So by the end of this lesson, you should be able to expand a quadratic expression. And just for introduction, we say that if we are given an expression which is k x plus y, we can expand this by saying, open the bracket, we have kx, and we have plus k multiplied by y, we will get ky. So similarly, if we are given a quadratic expression in terms of factors is written like this: x plus 2, and we have 3x plus 4. We can be able to expand this following the same principle that we have used up here. And this principle will say, we can say a is equals to x plus 2, and therefore we can replace our a there with the x plus 2. So we have a into bracket 3x plus 4, and that will give us the expression. So just like we have expanded here, we can open the bracket here and say this is 3ax, then we have plus 4a. But remember, we had assigned our a is equals to x plus 2. So we can start here by saying, instead of now x a, we replace our a with x plus 2, and we have plus 4, we replace our a with x plus 2. So we open the bracket. This will be 3x multiplied by x, that you get 3x squared. Then we have 3x multiplied by 2, that will give us 6x. We are through with that. So we multiply 4 times x, that will give us 4x, and 4 multiplied by 2, that will give us 8. Now, from our expression here, we can say that we don't have any term with 3 squared. We have 6x and 4x, they are common. So we can add up that and say this is 3x squared, 6x plus 4x, that will give us 10x plus 8. So that is how you expand a quadratic expression. And this is factors. Quadratic written is factors to get a quadratic expression. So that is how we do that. Let's do another example and see how we'll be able to get that. Our second example, let me create space here. We will be able to expand. So we have example 2. We just follow the same procedure. So we are going to expand x plus a, and this is a, and this is x minus a. So when you expand that, I want us to follow the same procedure we have done here. So we write one of the term, we can call it m into brackets. M is equals to, we get m is equals to, we can say x plus a. So we can now substitute our m here and say our term here will be m multiplied by x minus a. And just like we have done in the first 2 expansions, we expand here, we have, this will give us mx minus m times x minus m multiplied by a, that will give us our ma. And when you now substitute your m with x plus a, you have x, then you have m, that is not m, but x plus a. we have just substituted our m, and we substitute the other m, so we have our a x plus a. So you open the brackets, this will give you x multiplied by x, you get x squared. Then x multiplied by a, that will give us our ax. Then we do with that, so we say minus a multiplied by x, that is minus ax, and minus a multiplied by a, that will give us minus a squared, because this a is minus. So we start by writing our x squared. Ax minus ax will give us 0, and then we have minus a squared. So that is how you expand that. I hope you are following what we are doing here. So we are not yet through. We'll just do another example and see whether we'll be able to get the concept. So this time I want to expand 3x plus 2, and we have 4x plus 3. We just follow the same procedure. So I'll let this, I can still use my m. Let m be equals to 3x plus 2. And then I'll just replace that with our term here. So we have our m. We have 4x plus 3. Then you open the bracket, you'll be able to get this is 4. In fact, we can write it 4m. Then we have m multiplied by 3, that will give us 3m. From there, we substitute our m, so you have our 4x. Put your m, which is 4, not 4 but 3. This is 3x plus 2, and then you have plus 3. We substitute again with our m. Then you have 3x plus 2. So when you expand this is 4x multiplied by 3x, that should give us 12x squared. Then we have 4x multiplied by 2, that should give you 8x. We are through with that. We have 3 multiplied by 3x, that will give us 9x. Then we have 3 multiplied by 2, and that should give us 6. So what remains is now to put the right terms together. So we'll start with 12x squared. We don't have any other term that has x squared. We have 8x and 9x, so we can combine that. They are like terms, so that will give us 17x plus 6. So that is the expansion. What this means is that now our 3x plus 2, what we have expanded, and 4x plus 3 is the same as 12x squared plus 17x plus 6 when you expand. So that is how you expand, and you get your quadratic expression. So we are going to look at another example. So the other example that I have, I can call it, I don't know, example 4. Example 4. Let me correct that. We have example 4. We are told to expand and simplify. So the expression that we have is a half plus x into bracket squared. And to be able to expand this, we'll say that this is you know, when you have 2 squared is the same as 2 times 2. So we can write this is equals to a half plus x twice. Then we have a half plus x, like that. It is the same because it is squared. Now, Once you have that, you just follow the same procedure. You can say that your A, we can use A is equals to a half plus X. So what we do is we replace that with what we have. And when you replace that, then you'll be able to get this is A into bracket a half plus X. And you open the bracket, you'll be able to get a half A plus AX. So when you get that, then what you do is you replace your A back. So you have a half. So you have a half. Our A is our A. We had defined it here as a half X, a half plus X, and here you have then you have plus. We start with X, then we write our A is a half plus X. So now what remains is to expand that and be able to get, so this is a half multiplied by a half, that should give you a quarter. Then a half multiplied by X, that should give you a half X. We are through with that. X multiplied by a half, that should give us a half X. And finally, we have X multiplied by X, that will give us our X squared. So now, normally, we start with the, okay, we don't have any other whole number fraction. So we write this is a quarter. We have a half X plus a half X. That should give you a whole X. So we have plus X. And then finally, we have X squared. When you are writing a quadratic expression, we always start with the term with the highest power or index. So we start with X squared plus X plus 1 over 4. So that is the expansion of our example. So with that, I think you are getting what we are doing. And that is how you expand. I'll still go ahead and do one more example. So like I told you from the beginning, by the end of this lesson, you should be able to expand a quadratic expression. So we have, this is another example, expand and simplify. And simplify. And how do we do that? Okay, this is our example. We have 2 minus 1 over x, and this is squared. It is similar to the example that we have just done. So we are going to write this is equals to, we write it is 2 minus a half into bracket. I've told you that if you have 2 squared, it's the same as 2 times 2. So we are just expanding the square, and therefore we have this is 2 minus this is 1 over x. And when you have that, then we use the same procedure and say let our n, this time you can use any letter as long as you are comfortable with that. So, and that is our x. So what we do here is we substitute n. So we have 2 minus 1 over x. And when you open the bracket, this should give you 2n minus n divided by x. Now, once you do that, since we had defined our n as this term, we will just substitute that and say this will be 2. Our n was 2 minus 1 over x. And then we have, again, we have, let's have 1 over x. We replace our n with, or we still can just write it like the same fraction. That is, we substitute our n, which is 2 minus 1 over x. So I can still write it like that. And when you expand, then you open the bracket, 2 times 2 will be 4. Then we have minus, because that is minus x. We have, this is 2 multiplied by 1 over x. That should give us 2 divided by x. Then we have minus. This you can separate and write it like 2 divided by x. And then minus and minus will be positive when you multiply. So you have plus 1, and we have 1 over x multiplied by 1 over x. So we have our x squared. So once we have that, we have said that we always start with the term with the highest power. So we start with x squared minus 2 over x minus 2 over x will be minus, that will be 4 over x, because x is common denominator. Then we have plus 4. So that is how you expand that quadratic expression. I hope you have followed what you have done. You can do a few examples, more examples, and you find that it is not easy to, it is not difficult to expand. And that brings us to the end of our lesson. I have done quite several examples, so I think by now you should be comfortable with that. Check more examples from your textbook. I'm also going to give you an exercise. Once you do the exercise, you can send it back to me and I'll be able to mark for you and give you the result. So you can try these questions. Once you are through, you can send them to me. I'll be able to look at them and see whether you have understood what we have covered in this lesson. So you are told to expand and simplify. So the first question is you expand x plus 7 and we have x plus 6. So that should be easy for you. Then the other one you can do is x plus, that is x plus 3 squared. We have also covered something like that. Number 3, you can expand a x plus d squared. That's another one you can do. Use number 4, you can do 5x plus 2, and you expand, you have 3x plus 4. So that's another one. Then we have 5. We have x minus 5, and we have x plus 5. X plus 5. Then we have, let me put here number 6. You can expand a half plus 1 over x, and you square that. So that's how you, these are the questions you can try. If you are able to cover this, then you are good with that lesson. And that was the objective of this lesson. You should be able to expand quadratic expression. So join me to the next lesson, that is lesson 2 in this topic. And in the next lesson, we are going to deal with the quadratic identities.